Hey guys, Benji here, and I want to talk to you a little bit about some properties of the definite integral as we make our way forward. So the first property we want to talk about is that if you were taking the definite integral of f of x dx, but your limits of integration are the same, so from a to a, well, you're kind of taking the area under the curve, but your interval for which you're taking the area is zero. And so that makes sense that if your limits of integration are the same, that definite integral is going to have a value of zero. Um, the constant function rule is that if you have a function that itself is a constant, such as f of x equals, I don't know, let's say 3. So here's a little graph of what that looks like. Here's x, here's y, and let's say that f of x is just 3, some sort of constant. Well, I think it makes sense that if we're going to take the definite integral of f of x from the point where x equals a to the point where x equals b, well, you're going to get a rectangle, right? And its base here is going to be b minus a, and its height right here is going to be, well, whatever the value of that constant is, in this case, 3. And so it's no surprise then that the area of that rectangle will be the base of it times the height of it, so you will have this situation right here. Constant multiple rule says if you have some function and you're multiplying it by some constant, the definite integral from a to b of k times f of x dx, well, you can pull that constant out in front and multiply that constant by the definite integral here. Sum and difference rule, if you have a sum of functions or a difference of functions, you can take the sum or the difference of their definite integrals. Switching the limits of integration. This one is a little more interesting, which says that if this evaluates to a number, the definite integral from a to b of f of x dx, if you switch the limits of integration, so now going from b to a of f of x dx, these two integrals should be opposite signs. It's -1 multiplied by the other. So if one is positive, the other one will be negative, and if one is negative, the other one will be positive. And that really brings up an interesting question of having a negative value for a definite integral. We've been talking about these definite integrals, kind of thinking of them as an area under the curve, and what does it mean for that to be negative? So let's do a little quick example. So here we've got some function on the right. We haven't defined it, but let's say that the definite integral from 1 to 4 of f of x dx is 6.4. And I'll go ahead and kind of draw that. So we're saying that the area under the function right here, we'll say is 6.4. And we'll say that the definite integral from 4 to 6 of f of x dx is 1.4. And I will do that in a different color. All right, so we're saying that that's 1.4. So we got that in pink, we've got this in blue. So the question is, what would the definite integral from 4 to 1 of f of x dx be equal to? Well, we know that the definite integral from 4 to 1 of f of x dx, well, that should be -1 multiplied by the definite integral, let's switch the limits of integration here, from 1 to 4 of f of x dx. And I claim that we know that, right? The definite integral of f of x dx from 1 to 4 is 6.4. So this will be -1 multiplied by 6.4 for a grand total of -6.4. Very interesting. This is one of the first times we've ever had a negative value for a definite integral. And there are a couple of ways to think about this. One way that I like to think about it, maybe it'll help you, is we kind of talked about how each of these definite integrals was kind of the sum of infinitely many little rectangles, each of which having a height and having a width, if you will. And so one way I like to think of this, looking at this definite integral and this function right here, I think as we go from left to right, yes, the function is always taking on a positive value in this interval. And I would say the width of each of those subintervals, this little dx, an infinitely small delta x, if you will, is going to be positive, 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 positive. Now, if we think about going from right to left here, I think that, or rather here, so from 4 to 1, f of x is, again, going to be positive in this whole interval. I kind of like to think of this dx, this little infinitely small delta x, as we go from right to left. Each of these widths, I kind of like to think of them as negative, right? Negative, 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 negative. And so it's no surprise that the outcome there should be negative, as we're summing up a bunch of numbers, each of whom is a product of a positive and negative number. So that's one way to think about it. Maybe that'll help you out. Okay. And so here was a situation in which, right, the definite integral from 4 to 1 of f of x dx was equal to -6.4. That is crazy. One thing we can also use to our advantage is combining integrals of adjacent intervals. I'm going to zoom in on this for us for a moment, which says that the definite integral from a to c of f of x dx is equal to the definite integral from a to b of f of x dx plus the definite integral from b to c of f of x dx. And with this first example, I think it's going to, I don't know what happened there. And we're back. Okay, so with this first example here, I think this makes sense. Does it make sense that the integral, the definite integral from 1 to 4, so that's right here, that area, plus the integral from 4 to 6, right here, would equal the definite integral from 1 to 6? Yeah, that makes sense, right? And kind of putting some numbers on that, I think it makes sense that, 6.4 plus 1.4 is equal to, let's see, 7.8. So I'd say that the definite integral from 1 to 6 of f of x dx would be 7.8. Now, let's see if this is going to kind of jive with us. Would it make sense that the definite integral from 1 to 6 of f of x dx plus the definite integral from 6 to 4 f of x dx, would that equal the definite integral from 1 to 4 of f of x dx? Note how this equation right here is very similar to this one right here. What's kind of different is this 6 right here, which is kind of like these b's right here, does not need to lie between A and C. Does not need to lie between A and C. And that's a really, really, really big deal. And if we want to put some numbers on it, we already know that the definite integral from 1 to 6 of f of x dx is 7.8. We know that the definite integral of 1 to 4 f of x dx is, let's see, 6.4. So in theory, the definite integral from 6 to 4 of f of x dx, this should be a negative number. This should be negative 1.4. Oh, you know what? That makes a whole lot of sense, right? Because this should be negative 1 multiplied by this, negative 1 times 1.4. So an interesting kind of scenario here. 1, combining these integrals of adjacent intervals, and 2, the idea of having a definite integral at all evaluate to a negative number. All right, let's make our way to the next page. Right, so as we were talking about, big picture question, when is a definite integral going to be negative? So what I'm going to ask you to do in each of these cases, I'm going to ask you to take a moment to try to evaluate all of these definite integrals, and then I'll go ahead and walk you through them. So in our first example, we are asked to find the definite integral from 0 to 4 of g of x dx right here. So take a moment, pause the video, see if you can figure this out. All right, so I'm going to go ahead and we're going to use a little bit of geometry to our advantage here. So here is 0 to 4. It looks like it's all positive there. It looks like we've got a triangle. It looks like its base is 4. It looks like its height is 2. 1/2 times 4 times 2, I think, is equal to 4. All right. Now you try B on your own. Okay. Note that this right here, that is just going to be, well, negative 1 times the definite integral from 0 to 4 of g of x dx, just changing those limits of integration, so that should be negative 4. And that kind of makes sense, right? It's the exact same kind of region, but reading it from right to left instead of from left to right. All right, you pause the video, see if you can find the definite integral from 4 to 8. All right, in this situation, let's take a look here. I'm thinking that this is going to have a negative value, right? Because all of our f of x's, rather g of x's, are going to be negative, and our little dx's going left to right will be positive. I think it's the exact same kind of congruent triangle to this one right here, so this one should be negative 4. Awesome. You try D on your own. Similarly, we know that the value of this integral is going to be negative 1 times the value of this integral right here. We've just switched the limits of integration, so this will be positive 4. Once again, thinking about positive, negative, g of x is negative on this whole interval. Reading it from right to left, from 8 to 4, all those little dx's will be negative as well. All right, now you try question E, please. All right, so from negative 5 to negative 3, it looks like we're going to have a positive value here. Again, we have a triangle. Its base is equal to 2. Its height is equal to 2. 1/2 times base times height is going to equal 2. And for f, not surprisingly, once again, we just switched the limits of integration. So this is going to be negative 2. Last but not least, let's check out this piecewise defined function down here. And sometimes we're going to be asked to find the definite integral of something where we are given an equation. We kind of got to graph it. So f of x equals 5 for x is less than 4, and we're going to be evaluating the definite integral from 1 to 7. So let's go from 1 until 4. Let's see, x equals 5, so 1, 2, 4, right? That's this portion right here. And then x plus 1, we'll do this in blue. I like blue. So if x is equal to 4, okay, and then we're going to go from 4 to 7, so boom. I think that this is our piecewise defined function, and I just decided to cut it off at our limits of integration at 1 and 7. So now we need to find the area enclosed here. I'm going to go ahead and draw some lines to help me out. Let's see, I think the area here is 1, 2, 3, 1, 2, 3, 4, 5. I think this has an area of 15 square units. This one also has an area of 15 square units. I think that has an area of 9/2 square units. So I would say that the definite integral from 1 to 7 of f of x dx in this case is equal to 34.5. All right. So I hope you found this helpful, and I look forward to seeing you soon and picking up where we left off.